Hey there, data enthusiasts. Welcome back to our channel. If you're diving into the world of machine learning, you've probably stumbled upon the terms grid search and random search. Today, we're going to break these concepts down in a way that makes them easy to understand. So grab a cup of coffee and let's get started. But before we dive deeper, let me ask you, have you ever felt overwhelmed by the number of options you have when tuning your machine learning model? If you have, you're not alone. That's where grid search and random search come in handy. Let's explore what they are and how they can help optimize your models. First up, let's talk about grid search. This is a systematic way to work through multiple combinations of hyperparameters. Think of it like a road trip where you have a map with every possible route marked. You're going to take every single route to see which one gets you to your destination the fastest. In a grid search, you define a grid of hyperparameters you want to test. For example, let's say you're working with a support vector machine model. You might want to tune parameters like the kernel type, the regularization parameter C, and the gamma value. You could create a grid like this. Kernel 0.11, 10, gamma 0.01, 0.11. When you combine these, grid search will test every possible combination of these parameters. That means if you have 3 kernel types, 3 C values, and 3 gamma values, you'd be testing a total of 27 combinations. Sounds exhaustive, right? And that's one downside of grid search. It can be computationally expensive and time-consuming, especially with large datasets and complex models. But the upside? It gives you a thorough evaluation of the hyperparameter space, ensuring that you don't miss out on the best combination. Now let's shift gears and talk about random search. As the name suggests, this approach randomly samples from the hyperparameter space. Imagine you're at a buffet. Rather than trying every single dish, you pick a few random ones to taste. This method can be a lot less taxing on your resources. In a random search, you define the same hyperparameters as before, but instead of testing every combination, you randomly select a fixed number of combinations to evaluate. For instance, if you decide to sample just 10 combinations from that same grid of 27 possible configurations, you can potentially find a good solution without the extensive computational cost. Research has shown that random search can be surprisingly effective. In fact, studies have indicated that it can often yield better results than grid search, especially when only a few hyperparameters significantly affect the model's performance. This is because it can cover a broader area of the hyperparameter space in a shorter amount of time. For instance, a study comparing both methods on a classification task found that random search found the optimal hyperparameters more quickly than grid search. While grid search may still be beneficial for smaller parameter spaces, in many real-world situations, random search can outperform it. So, to summarize, grid search is a thorough and systematic method of hyperparameter tuning that tests every combination within a defined grid. It's comprehensive but can be time-consuming. On the other hand, random search offers a quicker, more efficient way to explore hyperparameters by sampling randomly, which can often lead to good results faster. Before we wrap up, I'd love to hear from you. Have you used grid search or random search in your projects? What has been your experience? Drop a comment below. And if you found this video helpful, please give it a thumbs up, subscribe for more machine learning insights, and share it with your fellow data lovers. Thanks for watching, and happy coding!